So in this video, we're going to have a talk about generations of programming languages, and this is this part of the specification here, classification of programming languages and translators. So what we're going to understand today is the difference between a high and low level language and the kind of major differences between the two. We're going to know a little bit about machine code and assembly language. We're not going to talk about translation for now, we'll say that for the next video, but we are going to understand the pros and cons of low level languages compared with high level languages. So let's start with the low-level and high-level languages, okay? So let's start kind of history of languages. So to start with, when computers were first designed, they used binary, also known as machine code. And it's important to remember that this is still used today. So all computers still only understand machine code. Everything else we do at a higher level, whether it's assembly language, whether it's third generation or third or fourth generation, they're all ultimately compiled or generated back into machine code. That's all the computer understands, okay? So machine code was the first generation, okay, and that was the native language, okay. So this is the most efficient. So it runs the best, it runs the quickest. It's super fast to run, as from a computing sense, because you don't have to translate it. However, it's incredibly inefficient because it's hard to code for. So obviously it runs fast, which is great. It's a really quick runs fast. That's the advantage. But the disadvantage was it's hard to code for. Because obviously, writing lots of zeros and ones is really repetitive for programmers. It's kind of doesn't make use of any of the kind of modern features we have, like selection, like if statements or looping. It's very kind of works its way through the code. It's also hard to spot errors. So, although it was a good baseline to start with, it wasn't the best kind of language initially. So then what happened was we moved on to something called assembly language. Now, assembly language, if you look, uses these things called mnemonics. And mnemonics are like these little command words like mov and add. And it was a little bit more English-like. It wasn't perfect, but it was a little bit easier for coders to kind of write programs in, because they could write things like mov this to this, or move this instruction to here, or add these two together, or that you could branch to different parts of the code. So although it wasn't perfect, it kind of worked a little better. Okay, so it made use of mnemonics, which obviously made it easier for programmers to code as well. And the other thing to remember about assembly is it's like for like with machine code. So what I mean by that is that if you write, oh, that's gone off the recording there. Let me see if I can rip that out. Right below code. So what I mean by that is if you write one line of assembly language, that's the same as one line of machine code. So if you have 20 lines of machine code, you will always have 20 lines of assembly. So it's kind of like for like, really, which works out quite nice. Your programs are no bigger or no smaller. That again is another benefit in that sense. So it made use of these mnemonics, made it easier to code. The major disadvantage really with assembly is that it had to be translated back. It had to be converted back into machine code, which isn't a problem. It's not a big process, but it's an extra step that's needed. So it wasn't as quick and as efficient as kind of machine code. Okay, we use an assembler for that, but I'll talk more about that in the next video. Now it's important to note that these two languages here, so kind of machine code and assembly language, these are both known as low-level languages. Oh, I don't know why my colour's not changing. There we go. These are both known as low-level languages. They're both low-level, okay? And the reason why they're low-level is because they can ultimately communicate with the hardware. So at low level, they can have a direct communication with the hardware. So like the CPU, for example, they can talk to it, they can talk to the hard drive, they can talk to other components, okay? Because they are very similar to how the computer actually works. These are low-level languages, okay? And low-level languages are great in many instances. They're quicker to run. They can communicate with the hardware. The downside to them is they're harder to code for. They don't have any of the modern complexities that we have today, and they're harder to error check and harder to do that kind of stuff. So, but assembly language is still used in certain areas on like embedded machines and stuff like that, in places where you don't need a lot of power to run, because they're generally quite small programs as well. So then what happened was we got to the third generation. Now, third generation is a bit more broad because this covers so many different programming languages such as Python, C++, Java, Visual Basic. you name it, these kind of languages all fall into that bracket of third generation. What makes third generation really different is known as a high level language because it uses high level features which are not found in the lower level ones. So, for example, things like if statements for selection, or using loops like while loop or for loop, or being able to use functions to jump to different parts of the code, as you wish. Those are not features found in lower level languages, okay? And also, these third generation languages use more English-like descriptions, don't they? So if you imagine, they use keywords like if and while and loop, words that we as people with language understand. We don't really understand zeros and ones, but we understand keywords. They make more sense to us. So third generation was more English-like, which was great. So for programmers, it was much easier to use, and the benefits of that, it's easier to error check because obviously you can see visually, like, oh, there's a syntax error there, I've spelt that variable wrong. You can see that much more clearly in a third generation than you can in one of the lower levels because that uses more mnemonics or zeros and ones. It also, like I said, makes use of advanced features such as like we said, looping, if statement selection, functions, all that kind of stuff, which you don't find in lower level languages. So it's much easier to code in, it's much easier to error check, much easier to kind of write these more complex programs. And it's not like for like with the one. So you can pretty much write a program that might take 200 lines of machine code in half that lines, maybe even less, because of these additional features that you can use. The major issue with third generation, another benefit of third generation, is you can also write code for multiple processors. So basically, when you buy a processor and it's built into your device, it only has a set number of instructions it can do. So it's very limited on what it can actually do. Every processor is different, so different brands and different companies, they have different instructions. So if you write something in assembly or machine code for a processor, it means that it might not run on it. You can't just take it and put it on a different machine because it might not work very well. It won't be cross-platform is the best way to think of it. And back in the olden days, especially back in the 80s and 90s, that was definitely a problem. But whereas on modern devices, like with third generation, you can write code in, just as you want to, and then you can basically export it or compress it or compile it, as it's known, and run it on different operating systems or ignore that, different processors, because these different processors are the ones that it will translate it for their instruction sets. So it doesn't matter that they're all different. So it means from your point of view as a programmer, that makes your life so much easier because you don't have to write the code 5 different times in 5 different ways. You can just write it once and convert it to work on those different processors. So back in the old days, you literally just would write it for one computer and that was it. It wouldn't run on any other devices. Even the same brand of computers, if it was a different year or a newer processor in there, it wouldn't work. And you had to really check compatibility. So the major issue with third generations is that basically it's not machine code. That's the major issue. So it has to be translated back into machine code, which is an extra step, which takes a bit of time, and that's your major issue, really. So again, it's not really a reason not to use third generation because we have resources to do that, which I'll talk about in the next video, okay? So yeah, we've already talked about that. We talked about the differences. We talked about the differences between them. We've understand that program code written in high-level language assembly must be translated. We've mentioned that, and the advantages and disadvantages of low level compared to high level. We've also talked about as well. So yeah, so advantages and disadvantages. Low level runs faster. It's obviously the computer's natural language, so it's easier for that. You can manipulate hardware with it, so you can communicate with the CPU and other things there. The downside to first generation, or low level, is that it's harder to code for, harder to spot errors, harder to error check. Whereas higher level, it's more English-like, easier to code for, easier to error check. The downside is it has to be translated back into machine code, which takes a bit of time, and you can't manipulate the hardware either. So it cannot manipulate hardware because it doesn't have access. So sometimes you have to translate halfway into something called a bytecode, which is something we can then use as like assembly to kind of do other things. There we go, guys. So quite a long video there, but hopefully that summarizes the differences between high and low level languages.